So traditionally a topic that students find a bit difficult, this one, so hopefully this video will help you to get your head around it. You know the quadratic formula. The quadratic formula helps you to find the roots of the quadratics. That's where it crosses the x-axis. So let's just have a go finding as a tattoo of the quadratic formula. I don't recommend it. I think there's much better formulas than that, but feel free. So the roots of this one, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's 3 over 4 plus or minus a quarter of the square root of 9 plus 40. So that's 3/4 plus or minus a quarter of root 49, which is 7. So basically we're doing 3 over 4 plus or minus 7 over 4. So that is 10 over 4, or 3 minus 7 minus 4 over 4, which is 5 over 2, or minus 1. So they're the roots. Hooray. Next one. Okay, a bit more complicated. Maybe not. Maybe a bit easier. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Just getting the a, b and c right there, that's all. So that is plus or minus the square root of 48 all over 2, which is plus or minus the square root of 4 times, well, 12, which is 4 times 3. All over 2, which is plus or minus 2 times 2 is 4 root 3, all over 2, plus or minus 2 root 3. Yeah. Hooray, next one. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is 4 plus or minus a half root 64. Oh. 4 plus or minus a half of nothing. 4 plus or minus nothing. 4. Only one answer. But we've seen that, haven't we? We've seen quadratics where they've only got one answer. Like that. It's a double root at 4. That's fine. Yep. Okay. Minus x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, which is 6 plus or minus the square root of 96 minus 44 over 2, which is 3 plus or minus a half root minus 11, 12? 8.
Still minus.
Yeah, problem. Can't square root that. So we've come to a halt. So it's not like well, I did go wrong because I said 11, but I haven't not got any answers because I can't find them, or because I went wrong. I haven't got any answers because there aren't any, because it doesn't have any roots. So I was obviously trying to find the roots, and there weren't any. Maybe it looked like that. And it simply doesn't cross the x-axis. Okay, another one? No, that's all. So, what we found was that I can always use the formula, and sometimes I get 2 answers, and sometimes I get 1 answer, and sometimes I get no answers. And the bit that caused that was this. That's the bit that caused it. This is called the discriminant, not the square root bit, just the b squared minus 4ac. That was the bit that in this one caused a problem, because b squared minus 4ac turned out to be negative, so I couldn't square root, so I couldn't find any solutions. And then we had the one where b squared minus 4ac turned out to be 0, so I ended up doing plus or minus 0. And then the first couple that were just what we'd kind of expect really, where we had a positive b squared minus 4ac, and then we square rooted it, and then we added it on and everything, and it all worked out fine. So that bit there, b squared minus 4ac, that's called the discriminant, and it's called the discriminant because it discriminates between these 3 cases. So, discriminant of 0, literally just 0, that's a quadratic with 1 root. Doesn't matter where it is. In fact, it could even be that way round. That's also going to have a bit of a funny angle now, but never mind. That's also going to have 1 root. So it doesn't matter where it is. It can be anywhere, but it just touches the x-axis. A discriminant that's negative, so the discriminant being a negative number, it makes no difference if it's minus 1,000,000 or minus 1 or minus 0.7. That's a quadratic where you cannot square root the b squared minus 4ac, so it must not have any roots. Up there? Yeah, it could be upside down and be down here, but it definitely does not go near the x-axis. These are the ones you would have seen in the GCSE exam. They don't cause any problem at all, these ones. So the discriminant being 1 or 2 or 20 million billion, doesn't matter, some sort of positive number. These are quadratics that you'd expect, normal sort of quadratics. They cross it in two places, doesn't matter, you know, what the two crossing points are. It might be that way up, it might be the other way up, it might be a negative quadratic, but there's two places where it crosses the x-axis, and then by using the quadratic formula you can find out what they are. So you've got your original quadratic and whether or not it crosses the x-axis, and then your discriminant being 0, negative, positive. Okay. In this question, we're told that the quadratic has one repeated root. Okay, which colour quadratic is that one repeated root? Green one, yeah. Green one's got one repeated, one touching root. So we know that b squared minus 4ac is equal to 0. Okay, what is a?
A is 1.
What is b?
B is k.
Yep, the amount of k, not 4. Oh, sorry. And c is 1, yeah. A is the amount of x squared, b is the amount of x, c is the amount of 1. And what we know is that one repeated root means b squared minus 4ac is 0. So do you want to sub in what we know?
So we've got k squared minus 4 1. So k squared minus 4 is 0. K squared is 4, so k is plus or minus square root of 4, which is 2.
Yeah, sorted. Done. It's that simple. Let's try another one. Okay, same quadratic, so we know A is 1, B is k, C is 1. But now we're told no real roots. So if we go back to which colour has got no roots?
This one.
Yeah, the blue one's got no roots. It's not crossing the x-axis. So we know that b squared minus 4ac must be less than 0.
So this is
less than 0, exactly.
So k squared minus 4 is the same number, it's less than 0.
Yeah, 4, 1, 1, yeah. 4 times, A is 1, C is 1, 1 times 1 is 1, yeah, that's right.
So k squared is less than 4.
Yeah, and that is a really good example of what not to do. Because, and this is what students want to do, and then the next thing is to say this. No, you can't square root over an inequality. So when we did quadratic inequalities, what we did was to work out what the roots were, and then draw a little picture, wasn't it?
Yeah.
So we need to.
Right. So we need to find what those.
Yeah.
Points
Can you factorise that?
Yeah, it's the difference of two squares.
Difference of two squares, exactly. Yeah, that's better. So the roots.
K minus 2 less than 0, or k plus 2. Well, technically it'd be equal at this point, wouldn't it?
Yeah, you can't really, where you've got a quadratic, I know it's tempting to do that because where you've got a quadratic equals 0, either this one is 0 or this one is 0, that only works with equaling 0. Because if you say A times B is 0, then either A is 0 or B is 0.
Yeah.
Agree?
Yeah.
If you say A times B is positive, can you say, in that case, A is positive or B is positive?
No, they both have to be positive or they both have to be negative.
Yeah, they could both be positive or they could both be negative. So that kind of argument doesn't go in that direction. So what we need to do is look at the graph.
And not be tired when we talk to students.
Yes.
Well, we know that when it is 0, the points are k equals 2.
Yes, exactly.
And k is minus 2.
Yeah, exactly.
And then we're looking at where that quadratic, this one here,
Yeah.
is less
Yeah,
than
less
height
than,
zero,
less than, height less than 0.
which is all of
Yes,
this bit in
that's
here.
right.
So k is going to be between -2 but not including.
But not including.
And
Yeah,
less than 2.
so we need to be between 2 and -2, but we can't equal either of those things because it's just less than.
So that is where this equation, so k varies, but it will still give you no real roots.
Yeah, exactly. I mean, let's try one. Let's pick, should we pick k as 1 because it's easy?
Yeah.
So 1 is between -2 and 2. So just as an example to check it works, if we try now to use the quadratic formula, we would say, right, well, the roots are -b plus or minus the square root of b squared minus 4ac all over 2a, which is -1/2 plus or minus 1/2 root 1 minus 4. So this is where we get stuck, because we can't do the square root of -3. So the k is 1 is an example, oops, not, well, actually -1 as well. K is 1 is an example of a particular k for which this quadratic has no real roots, but there's plenty of others. Everything between -2 and 2 would do that, exactly. Okay, we've got a different one now. 2 distinct roots. Let's just go back and check our thing. So the red one, it's got the 2 distinct roots. This one's got 2 distinct roots. So the b squared minus 4ac, the discriminant, is actually going to be positive. Yeah, so what's A, what's B, what's C?
A is 1.
Yep.
B is the coefficient in front of x, so it's
Yep.
going to be 2k.
How many x's? And C is just everything else.
K plus 2.
Exactly, yeah.
Okay.
And we know we want b squared minus 4ac to be positive. Yeah,
So
positive number.
2k squared
Excellent use of brackets.
minus 4, thank you so much. K plus 2.
Bigger than 0. Yep.
4k squared
Excellent.
minus 4, forget about the 1, k plus 2.
Yeah, 4 times 1 is 4, so.
4k squared, sorry, it's beginning to look like 2k's or something. 4k minus 8. 0. So we've got quadratic.
Yeah, we want to solve this is naught so that we know what these are, because what we want is the positive bits. We want the height to be bigger than naught, so these bits. So we want the k's to the left of whatever that is, and the k's to the right of whatever that is. So we have to find out what they are. But that divides by 4, doesn't it?
So k squared minus k minus 2 is 0. So we're going to get k minus 2k plus 1.
Yep.
So k is 2 and k is minus 1.
Yep.
So we're going to end up with k less than minus 1 or k greater than 2.
Perfect.